Actually, the worst part is because I was there, I couldn't blink.
Really?
So my contacts got all dry. So it took like a while for me to like read my hair.
You're completely paralyzed.
Yeah, I think so.
But you could talk.
Yeah.
But you couldn't blink?
I wasn't aware if I was. I didn't think I was.
That's crazy.
Well, so just your ears and like mouth is working.
Yeah, I don't know.
You were able to talk.
I could talk. Yeah, just like this.
But you can't. Okay, so your muscles must be paralyzed.
I guess. I mean, they didn't like do anything. It was just a little tiny. They did like a little tiny shot thing. They laid me down first. They said, "This is gonna pinch." They didn't even do that. Then I was like this, yeah.
But they must have to avoid that because like few months ago, like my brother-in-law, his friend also got that problem, and because he had a surgery, and then they said no, you can't drive, so we can't give you a leave from here.
Mm-hmm.
And so he got worried because he has nobody is here because my brother-in-law was not here. He was on.
Well, yeah, but then Romano would have been happy. They would have just kept me in the hospital.
No.
That's what I heard. You said, "Hey, I wish class was canceled. They would have kept my professor in the hospital." Isn't that what everybody else heard?
No.
That's how we get a test.
So that's good for you like this.
And that's how I failed this class. Oh. Okay, so let's go through our slides up to this point. And so what we're going to do is next week we're going to have how did your teacher do in your other class? Did you just take a test and leave, or did you really? We don't want to do that. We want to stay. Well, no, I figure I'll make a test. It'll take like an hour, but I'll give you 15 minutes to do it. Because I already made this mistake yesterday with my Indian students in 535, because they had a midterm in there and it was like an hour, something like that, right? But some of them felt stressed with the time for an hour test. So I'm like, okay, I'm going to make the final exam the same length as the midterm. Okay? I'm going to give you 3 hours to take it. So I solved their homework for that week, for the last week, the first hour, 45 minutes, whatever it was. And I gave them the rest of the time for this test. They took all of it.
Really?
They didn't need all of it. If I had given them an hour, they would have been done in an hour.
Yeah.
I mean, same length test. Yeah, maybe a couple of problems were a little more difficult, so slap 10 minutes onto it for actual time commitment, not 2 hours. All right, so let's go through this and let's find out what's going to be on this test, and then we'll negotiate how we'll take the test. I could be really evil, and we can have class for 3 hours, and then a test the last hour when you're already tired.
That's savage.
Well, I mean, she wanted me to stay in the hospital.
Yeah.
Oh my God.
This is on her. What do you think I'm that mean?
Well, I meant I was expecting a bus.
My LaCroix went down the wrong pipe. All right, so let's. I'm not going to ask you questions. I mean, all this stuff we've talked about in here is important in context, in the big context. What I'm going to go through here, I'm going to kind of point out things that I think are test worthy. All right, so I'll try to zero you in on things. As I've mentioned before, I like conversion questions. So you should expect there to be at least 2 conversion questions between bases and stuff like that. Those should be pretty easy. So make sure you understand both patterns, and those should be free points. If you've had my test before, have any of you had my test before? Very interesting. That doesn't happen to me very often. Because, I teach in the grad program too, but a lot of our grad classes are 8 weeks classes, and they've had me for the research class and for the programming class. Programming was project-based, and the research class was not something you test over. So this is your first class that you'd have a test. Oh, my tests are impossible. People cry.
Seriously?
Oh my gosh, this is the thing of nightmares. I got good news. Want the good news or the bad news? Got more bad news. All right, so all my tests follow the same format. There's 10 questions. 10 questions, all short answer or programming or something like that. So never true, false, never multiple choice. So just 10 questions, each one worth 10 points. Some people say they don't like them all being worth the same, but that's what it is. So you'll have some questions that would be free 10 points and then other questions that are impossible. All right, but I give you partial credit, so make sure you show me as much as you know how to do. I do have a policy in all my classes, and I think this is a good one. I should get bonus points for this. Because all my classes, if you look at the syllabus, we have a midterm and a final, right? Well, in all my classes, I have a policy that if you do better in the final exam than you did in the midterm, I'll replace your midterm exam score with whatever you got in the final. All right, so if you screw up the midterm, you get to fix it with your final. I've had that happen before. I've had a student get like a 10% on the midterm. I get a 95 on the final. This thing's just clicked somewhere in there. A in the class. Right? So it's a good policy, right? It's bonus points. That's legit, yeah. Way better than wanting a professor in the hospital. Drinking out of a sippy cup. I mean, who even says they want their professor drinking out of a sippy cup? Why'd you say that? All right. So plan on there being at least 2 conversion questions. I like those kinds of questions. I'm not going to ask you a question like, what's a computer? But I assume you know that kind of stuff. But questions will not be like that. I'm not going to ask a blanket question like, what's a computer? It'll be a very specific question. My questions tend to be more applied. So I won't ask you to like define something where I'm asking you to like memorize some 2 or 3 sentence definition for something. I want you to show me that you understand a concept as opposed to that you memorized 3 sentences from the book or something. All right, so whenever you're answering questions on my exams, write stuff that you think will ultimately convince me that you know what you're talking about. Even if you're having to use, like you can't come up with a certain word, use another word that at least shows me you know what you're talking about. Because I'm mostly great on competence as opposed, book smart doesn't cut it, right? You need to understand the stuff, and just because you don't know what something's called doesn't mean you don't understand it. Definitely understand the concept of a CPU as kind of what we've talked about it in terms of a collection of magic tricks and things like that. Certainly fair game things on the exam. You might even look at it from our simulator perspective would be some of the commands that we've implemented in our Android simulator. We'll go back and look at that some today. But understand that concept of the hardware registers, moving things into memory, adding and subtracting, and loading things into RAM, storing things into we load into registers, store things into RAM. So those concepts. All right, I'm not going to ask you about some strange instruction that we haven't really discussed in class. So I want you to understand that whole low-level instruction stuff and how it relates to CPUs. But it's only going to be stuff that we've really discussed or even implemented in our. I'm not going to throw you for some loop asking about some instruction that was number 48 on that list of instructions on that page that we never even talked about. Okay. Nothing from there. could be something with data sizes. That's again a conversion type thing. So I want you to understand that 1024 pattern. It would be fair game for me to say something like some giant number of bits equals how many megabytes, something like that. So be able to do those conversion things. Those things become so important in computer architecture because they're specifically the memory, the bases. But even the data size type thing, when we actually have to start thinking about how much stuff is stored inside of a specific register, these things are so important and they're so often glossed over because we just don't worry about it. Like, oh, I have a 16 gigabyte jump drive, so it's just fine. So expect conversion questions. In fact, half the test is probably going to be math like that. So if you've gotten good at those things, then you're sitting at least a 50, okay, probably on the test. We should appreciate that memory used to be really expensive, but that's not something I'm going to test you on. Same thing there. A conversion question for speed or something like that, or for data size, could come in the form of something like this. If I said you have 120 megabit per second internet connection, how many kilobytes per second can you download? So I might hide the conversion inside of a question like that. But it's still, you're converting between megabits and kilobytes. Something from this slide probably could find its way in there. It should be kind of free points, I would think, or something along those lines. Just the different hierarchy of memories that we have. The closer to the CPU we are, the faster and smaller the memory tends to be. So you should certainly understand that the fastest possible memory we have to work with are our registers. After that, we move away to our caches. We didn't talk really about the specific differences between L1, L2, L3 cache, so I won't ask anything about that. But just that there'll definitely be something on there related to registers. Okay, but understand the concept that the closer you are to the CPU, the faster and smaller memory is. So in our world, the things that we really care about and the things we've been talking about more recently is registers versus RAM. That's the whole load and store stuff we've been dealing with more recently. All right. So RAM would be relatively big, relatively slow. Registers would be relatively small, relatively fast. We're actually kind of really fast. Not even relatively. It's just, as far as memory goes, it's fast. That's if we can build, why don't we just build all of our memory out of RAM, out of registers? It'd be really expensive. And you'd lose a whole bunch of speed because, one of the reasons why registers are so fast is because they hold very little, so everything is a direct pin out. Okay. Where if you start trying to create a chip with all these things linked together, it would get slower because of and hotter. Be a lot of heat. All right. Yeah, so all the number-based stuff. It would be fair game for me to ask you to convert something from like base 4 into base 16, okay, or base 7 to base 22, right? So you should, just because the base doesn't have a name that we're used to, octal or hexadecimal or decimal or binary, doesn't mean you can't convert between them. So understand those patterns. That's a big, actually, were any of you stopped in, Ramona, at the CS get-together today, right? So did you hear some of the questions?
Yes.
So a lot of conversion stuff, right? So, I know it's not that much fun, but it's really, really, really important. And it's one of those things that 90% of the time when you're in industry, you won't need it. It's that 10% when you do that you'll wish you understood what everybody else is talking about. Right? So I want you to get to the point where all this conversion stuff becomes boring and you're like, why is he asking me this question again? I guess he wants to just give me free points. Then I know my work is done. All right? So very likely, I will ask you to convert from some unnamed base into another base. So like I gave an exam today in another class because I have conversion questions in almost every one of my tests regardless of the topic of the class. It was convert base 4 to base 16, which is actually an easy one because you can do the trick with nibbles. You can do 2-bit groupings. But in any case, more than likely they didn't use the trick, the class it was in. So they converted it long way, but you should be able to do that conversion because it's the identical pattern, right? All right, so we did a bunch of practice with those things. There's our second pattern where we divide and record the remainders. All right, and of course, I think we agreed that if we do something bigger than base 36, we'd switch over to Klingon for the next. Oh, she's. Remember we talked about Klingon? I said I think we agreed as a class that if we wanted to do something greater than base 36, because we're out of letters in the alphabet, that we would just start off with the Klingon alphabet. Didn't we talk about Klingon in here from Star Wars? Not Star Wars, Star Trek, sorry. But it's a real alphabet. You looked it up?
I looked it up, yeah.
Yeah, like somebody actually wrote the Klingon out. There's symbols and everything.
Yeah. Isn't there a language or something? Or didn't they make a language?
I'm sure.
Yeah.
Yeah, I think it's highly likely that. Yes. Okay, let's see. File system stuff. No, I'm not going to ask you about that. All right, so something along these lines could be on here, the various language types between our high level and low level. We've been working with a low level language, so understand that one-to-one relationship with the CPU. So for us, every instruction that we're writing is equal to one little magic trick on the CPU. One thing that the book takes you through, and we'll look at this in a few minutes, is they have you, I think the sample language they use is either C or C++, but they have you start off with some high-level code. They say, what would the equivalent low-level code be for that? How do you break that down into low-level code? I don't know that I would have you do that directly on an exam, but you should certainly be able to read low-level code. So if I gave you, 5 or 6 or 7 lines of ARM instructions that we're familiar with, or if I told you here's 5 instructions and here's what each one does, so if I used one that we haven't necessarily discussed, I would give you the information. You should be able to tell me what the final state of the registers are after that. So some of those might do some adds or something like that, so you'd have to do some binary arithmetic, that kind of stuff. So be able to do that. I don't think I'd ask you to, in fact, I'm pretty confident I'm not going to ask you to convert something from a high-level language into the low-level equivalent, even though that wouldn't be all that difficult if it was a simple enough line of code. But I think I care more about the stuff that lives in the registers and being, knowing how to add binary and that kind of stuff, how that works. Okay. I will probably have at least one question dealing with C stuff in here. I don't think I'll have you. Well, okay. If I had you write some C code, it would be something along the lines of, use malloc to create an array and fill it with some stuff, proving that you can generate new memory in C. More likely, or you would probably definitely have a question like this one, where I would give you some C code and ask you, what does this do? So you should be able to read the code and tell me How does it work? And I wouldn't write code that tried to trick you, but I would probably purposely name the variables generic, like A, B, and C, instead of meaningful variable names. So I'd ask you, what does this code ultimately accomplish? And when I'm asking something like that, I'm not asking you to tell me, that line 1 does this, line 2 does this, line 3 does this. I want you to tell me as a whole, what does this program do? If you got this input, this is what the output would be, and it's effectively adding all the odd numbers or something like that.
So you said you would have some writing C code too?
There might be a writing, it's possible, but I would ask you to write something pretty simple. So you should be capable of effectively allocating new memory. Our theme at this point for the first half of the semester is memory, right? And stuff that lives in memory. So in a class like this, even though we've done some programming stuff, I'm not necessarily going to test you on programming logic stuff. I care more about, appropriate topic for architecture is going to be what lives in your registers, what lives in RAM, and how things get from point A to point B, as opposed to those business logic things, which is really how we've been exploring some of those concepts by implementing them, but that's not something I'm going to test you on. Like testing you whether you could write something in Android isn't an appropriate testable topic for this class. It's been something we've been using to explore architecture concepts, but not, if you come out of this class and you can't write Android stuff, that's fine. You probably would have struggled with some of the homework assignments, but I'm not going to test you on Android coding on an architecture exam. Make sense?
Yeah.
So as it relates to C, if I had you write any C code, it would strictly be around, allocating some memory or something like that, and maybe writing a quick for loop. But, if I'm thinking about it right now, I probably would ask another conversion question or something like that. So I might come up with a couple of somewhat nasty conversion questions. So you have to do kind of extra math. So have your calculator warmed up for the for the exam. All right. Something from this slide could find its way on here. We've seen it represented on the with our emulator, where we have a kind of a base address for something and then an offset from there. So you should understand this idea that if I allocate some memory, so this is kind of Java code here, but if I wrote the same guy here in C, I would create something like a int pointer AR is equal to malloc 5 times size of int. All right, and that's going to give me some memory. Those two lines are equivalent. This is C, this is Java. All right, and that's ultimately going to put in AR some address. And that's the base address of that chunk of memory. And then you're going to take steps through that of size, whatever type you have created, whatever type of pointer you're dealing with. All right, so if I want to get to bucket 3, that's going to say, go to the base address, add to it 3 times the size of the data type you're working with, and that gets you, so if an int is 4 bytes, 3 times 4 is 12, 100 plus 12 gets you to 112. That's bucket 3. So it works that way in C, it works that way in our emulator when we wrote our memory as well. If we're going to put stuff, I think our emulator was 1 byte steps by default, right? We just mimicked what the thing was from the book, but understand that concept of a base address and then an offset from that base address. It's entirely possible I will give you some assembly code that does something like that, and I'll ask you, what's the result of this? All right, where I store something into memory that is, at some offset, and then I load something into some register from that offset, and you need to prove that you understand that, well, I started here, I went to offset 30 from that, so the value we actually brought back into the register is this guy down here. All right, so be able to read that code and understand that offset stuff. I won't ask you about history of RISC stuff. That's really, almost our backstory of how we got to ARM has become popular now when RISC kind of died before. Important from our historical point of view, but now we're just looking at a low-level language that's in the ARM instruction set or the LEG instruction set from the book, whatever. Yeah, so all this stuff, good stuff, but not something I'm going to test you over. Something here could find its way on the test. If I'm looking for a filler question, just the concept of compatibility, the difference between an operating system and the architecture itself. So, when we're writing low-level code and we have, and we're leveraging the underlying operating system by calling one of the system calls or something like that, we looked at like the Hello World program in here, right? And that particular program was Hello World in Intel assembly, but for Linux. So it was using Linux system calls. So we were loading into EAX the number 4 for whatever that system call number was for doing syswrite out to the screen. That code would look different if we were on a different operating system, even using the same instruction set. If we were still using the Intel instruction set, but we were writing that code for Windows, it would be using different system calls to accomplish the equivalent of syswrite. All right, so one of the compatibility issues that we need to work with is when the software was compiled, what ultimate OS was it compiled for, right? And then also when a software was assembled, what was the low-level language it was assembled? So the assembler that turns your high-level code, well, the compiler that turns your high-level code into low-level code, that guy is going to target a low-level language. So there's nothing that says you can't turn C++ code into ARM, and at the same time you can turn the same C++ code into Intel assembly, x86 assembly, right? It would be just a different compiler that converted between those two low-level instruction sets. Now those two low-level instruction sets now are only going to be compatible with CPUs that understand that instruction set. Make sense? So if you have some ARM assembly code, don't try to run it on a Core i7 Intel chip. Won't work. Doesn't understand the instruction set. So we have two different kind of compatibility levels. One is the low-level language relative to the hardware architecture of the CPU. All right. The other one is the low-level language in terms of the system calls of the underlying operating system. So the Hello World program written in ARM will look different. Well, I mean, it's going to be more common to see that in Intel x86, but it doesn't matter whether you talk about that or ARM. But so the Hello World program in ARM will look different if we're writing it for Linux than it will if we're writing for the Mac versus we're writing it for Windows. It might look very similar, okay, but at the very least, it's going to use different system calls and have the interaction between the CPU and the operating system, how we interrupt and turn things over to the OS, that kind of stuff, might be a little bit different depending on the operating system we're working with. We just to kind of talk about that just a little bit. So here's my kind of go-to guy, and then I'm going to do Hello World Windows assembly. Okay. All right, and we'll walk through that guy. I think it looks scarier than it actually is, but we'll walk through it here in a second. But the Linux one is pretty quick and clean, so we'll look at that first. So right here, the big deal here is this interaction between the Linux kernel and our low-level code. So the Linux kernel, this is our move right here. This is how we interrupt the CPU and tell it to turn things over to the Linux kernel. Okay, that's the command. Okay, so that's a very specific thing. This is a memory address. This is where the the bootstrap to the operating system lives in memory. All right, so it's hard-coded in memory. That would be different in a different operating system, or at least could be different in a different operating system. All right, so the whole reason we've loaded things into these 4 registers for the message, the length of the message itself, where we want to write it out to, and how we're writing it, this is our system call, is because that's what the Linux operating system call dictates. So we had to write it this way for Linux because this is what Linux expects for you to write something to the screen. Similarly, this is what Linux expects for a program to end, for you to tell the operating system to kill off the process control block and all that stuff. All right, we go over and look at the Windows equivalent of this. We'll call it rough equivalent because it was probably written by, well, it was written by somebody else. But we notice down here, we kind of have something similar, right? We have our string, or hello world data byte. All right. And, we have some stuff up here. Don't worry about these are like libraries and things that they're bringing in. What are we doing up here? So we're, this is creating some local variables. So we have bytes. So we have a bytes written, which is going to be equal to -4. I guess we're going to count down. We'll see how they use it here in a second. We're moving ESP into EBP, names of registers. This is a very new, this is probably written for a very new Intel architecture. Because, as we get to Core i7's 8th generation, you imagine they keep adding new registers onto these things or new other things. So, AX, BX, CX, EAX, EBX, ECX, we start getting into other, these are pointers. Okay, so here's kind of our standard output thing for Windows. So this is equivalent, that line right there is equivalent to this line right here. The Linux operating is expecting us to load into EBX the unique identifier for what output stream to use. We're using the standard output stream, which goes to the screen of the computer. So here we're getting the standard output handle. So this is the function that's built into Windows that grabs the standard output handle. It's equivalent to that guy. And then we're going to go ahead and associate it with every program as we have this stack. So we're going to push onto that stack this guy. All right. And then we're making a call to the operating system to process what's on the stack. All right, then we're moving EAX into EBX. Do we see what was in EAX at this point? I don't see an EAX written anywhere there. Let's just keep trucking through here. All right, so this is all stuff working with the stack. So what we're doing here is we're pushing things onto the stack, and this whole approach here is kind of the same thing as this approach right here. So rather than load up 4 different registers with some specific values that we're going to use for this writing out, in Windows expects you to get these various values onto the stack. Right? They want you to push these things onto the stack, and then when you turn things over to Windows, they're going to pop it off the stack to get the values it's expecting, as opposed to looking at EAX for one thing and EBX for another thing, and so on and so forth. All right, and then this guy right here, so call write file. So that is an inline function. That's really weird how they wrote this. That's fine. So this guy, they're calling it writing a file, but this uses that file writing, but they're writing it out to standard out. So instead of it being to a file, it's to your standard output stream. And this guy ultimately loads everything up, calls write file, and Windows, the operating system, will process that stack and ultimately get stuff out to the screen. This part right down here, we're pushing onto the stack a 0. What's that equivalent to? That's equivalent to us moving a 1 into EAX, kind of setting it up to make the program exit. And then what are we doing here? We're calling exit process, which is the equivalent of interrupting the CPU for this. So we see it looks very different, but we also see there's similarities between the two of them. But there's kind of different rules if we're interfacing with the Linux operating system versus interfacing with the Windows operating system. You know, I personally like Linux better, but POSIX has been around for a while, so it's Windows spent a long time being very proprietary, so their stuff purposefully was I don't know, maybe written kind of weird, but ultimately we saw it pretty much does the same thing, right? It accomplishes the thing in a very similar way. All right, so hopefully this kind of exemplifies at least this idea of compatibility between depending on your architectures as well as depending on your operating system. Those two different things can drive it because both of these programs we just looked at here are the exact same architecture. These are both Intel-based assembly. Well, I wouldn't ask you to read anything like this or like this because we've been focusing more on ARM. But I would ask more of a high-level question like maybe will a program compiled on, would a C program that was compiled on Linux for Linux run on a Windows machine? Why or why not? Explain something like that. So I'd ask you to, explain that even if the core architecture of the processors, so if both of them are running Core i7 Intel processors or something like that, even though the processors are architecturally equivalent, because it's running on a different operating system, the compiler on Linux would have made the thing work in terms of the Linux operating system. The low-level code would have been written in terms of the Linux operating system, so it would not have transferred over to the Windows operating system. It wouldn't run on there because it wouldn't know how to talk to the Windows operating system. It doesn't speak the Windows language, if you will. That make sense? Yeah. So kind of a higher level question like that. And this is kind of in that same vein, talking about the job of the compiler. So when the compiler is converting your high-level code into low-level code, it's, it has a target architecture for, am I converting it to low-level code for Intel? Am I converting, and which version? Is this old x86 or is this compatible with the latest, greatest Core i7, 8th generation, whatever? But what architecture am I targeting and what operating system am I targeting? Those are two variables that go into a compiler that tells a compiler what kind of low-level code to spit out. Right? And not every compiler is going to know how to do everything, right? Certain compilers, like for instance, Microsoft's C++ compiler, all this might have changed now since I think they support GCC now. But I know for a long time, Microsoft's Visual C++ compiler was very good. But it only compiled for Intel architecture on Windows. It was just the version of Windows it was compiling for. Because if you've seen it before, you've had some programs will run, like let's say you had a program that ran on Windows 95, and then you try to run it on Windows 10 and it won't run. It's possible that something has now been removed from the Windows operating system that was present in Windows 95 and now has been changed with how you use it. So you can try to run that program in compatibility mode where you tell the computer to pretend like it's Windows 95. So even though back then it was the same architecture, even then we're saying that our architectures, Intel architecture today is a superset of the previous one. I'm sure there's examples over the last 20 years where certain things have changed enough on a CPU to possibly make one CPU incompatible with another, with a future version of itself or a past version of itself, depending on which way you're looking at it, for some very specific example. Some specific example. in general, it's safe to say that all Intel processors are supersets of the previous processor, or all previous processors are subsets of the future processor. So you're backwards. If you have an older program, it should run on the newer architecture, because they should have all the stuff the older architecture had and then some. But it might not necessarily run on the newer operating system. If some of the system calls have changed, or maybe the number of parameters that are passed to the system call has changed, all of a sudden your low-level code that was compiled into this program 12 years ago that doesn't know about Windows 10, so the compiler that was written 12 years ago doesn't know about Windows 10, maybe isn't giving it the correct directive that has now been introduced into Windows 10 to make programs run correctly. So in order for your program to run, you might have to run it in compatibility mode, where you basically tell the operating system to act like an older version of itself. So if you really think about Microsoft, that's a pretty interesting and difficult problem they're solving. If they're gonna keep coming out with operating systems, they're gonna keep trying to make improvements. They might be breaking old stuff, right? So then you got to decide: do I care? Yeah, I do find it interesting. Historically, I guess society has attempted to, I think, demonize Microsoft to an extent. I mean, not that Apple gets any better treatment. Apple's more of the love-hate thing, right? But I think everybody kind of just assumes that Microsoft's kind of the big bad wolf, But it is kind of interesting how much work Microsoft puts into trying to make your old stuff still work on their new computers, their new operating systems. I always find it funny, even though I use Macs pretty often just because of the convenience, and it's light and stuff like that. I always find it funny how much people throw Microsoft under the bus when they've done some amazing things. Yeah. Just think about the number of computers that Windows 10 runs on. Or, you have plenty of computers today. I mean, some of you are probably still running Windows 7, right? Everybody's on Windows 10 in here? Really? It's actually interesting. That's a kind of a thumbs up for Windows 10. I mean, Windows 7 was a great operating system. People liked it.
I'm not about Windows 8. That was pretty good.
And then, so Vista was a little bit, Vista wasn't a bad operating system. It was just annoying to use. But Windows XP, super popular. You can still run XP today. I think you could be just fine with XP today. That says a lot. XP would run really fast on today's stuff. It just wouldn't take advantage of some of the newer architectural bonuses, because XP didn't know about stuff that came out this decade. But in any case, this whole concept of compatibility, I think, is an important concept from an architecture perspective, because when we're thinking about that low-level code, it's not just about creating ARM instructions for your computer. Because even though both Google Android devices and Apple iPhone devices are using ARM-based processors, Apple has their own, a whatever chip, and then on the, I think they're Qualcomm Snapdragon chips on the most of the US-based Android phones. So even though they're two different companies, it's almost like AMD versus Intel, they're both still ARM. They're both ARM architecture. But a program that was compiled for iOS will not run on an Android device because the operating system is different. The way that the low-level language talks to the operating system follows a different cadence. That makes sense? It is kind of interesting when you think about it really from an architecture perspective over the years. Why we haven't, we've come up with a lot of standards otherwise. We have REST-based APIs that have all decided that we're going to follow the HTTP protocol for if you have a program that needs to talk to a third-party data source, we always do it using HTTP functions that have been around since the day the internet was born, because that's now a standard, right? So in a lot of other parts of computing, we've come to these standards. Why haven't we standardized the way that a low-level language talks to the underlying operating system? To a certain extent, we have. So all POSIX-based operating systems would have that standard. Okay, so I think if you looked at a Hello World for the Mac, it would look a lot more similar to what we saw with Linux. The system calls might have a little bit different names or a little bit different order because technically the Mac is based on OpenBSD, which is a Unix flavor as opposed to Linux, but they're both POSIX compliant, so it would be close. It wouldn't look as foreign as the Windows one did, which is primarily stack-based. But it is interesting that we haven't come up with a standardized way of talking to any old operating system. And I think that goes, I'll throw the, why do you think that is?
Because of the big companies.
Yeah, I mean, the competition. These companies have been largely proprietary for years and years and years, right? I mean, Microsoft is still closed source. Linux has been open source since day one. Unix was closed source for a long time and then was kind of forced into open source just out of survival, right? I mean, you had a project called FreeBSD, which was Berkeley standard Unix, but the free version of that. So that was open source, and all of a sudden you basically had BSD source code released, so everybody else released theirs too, because Linux was taken over. Why pay somebody $1,000 or many thousands of dollars for an old Unix operating system that is super, 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 super stable as long as you have hardware that's 20 years old, but it's not going to work for anything new because they're not coming out. I mean, heck, those operating systems didn't even have driver support. It was just a different way of thinking about operating systems, right? But it is interesting that Windows, as they've continued to release new versions of their operating system, always held the course. Because they would have had, in order for them to switch to, let's assume POSIX is the answer. So I keep referencing POSIX. POSIX is the standard that all Linux and Unix operating systems adhere to. And if you were to summarize, how many of you have heard of POSIX before? At least heard PO. Here, I'm going to write it. Let's write it in the very next slide here. This guy right here, POSIX. We've seen that word before? Okay, so this is a standard, what's called a standard implementation for an operating system. It really talks about a lot of different things, like the file structure and stuff like that. But if we were to dumb POSIX down to just one line, we would say everything is a file. That's POSIX in a nutshell. You want to talk to your USB Bluetooth adapter? That's a file. You write to that file, and that behind the scenes magically talks to the Bluetooth thing. So everything is a file in a POSIX operating system. Because it became a very good way of writing operating systems, because we've even seen it just a few minutes ago. We're talking about output streams. Whether we're writing to the screen or we're writing to a file on the operating system, it's the same logic. Just the destination is different. But Microsoft differentiates between the two, okay? Because they're not POSIX compliant. Even though at the end of the day, the logic is the same. There's two different function calls. One if you're writing to the screen, to one of your standard output streams, and a different one if you're writing to a file, specifically a file. Where POSIX operating system, it's the same function. Because a file is a file is a file. It doesn't matter whether that file leads to your screen, leads to a Bluetooth device, or leads to a file on your hard drive somewhere. But it is interesting when you think about Microsoft, how they have held the course over the years. Because in order for them to, let's assume, I mentioned a minute ago, let's assume POSIX was the answer. In order for Microsoft to switch to POSIX, what would have had to happen? What would the fallout have been related to that?
Older applications would not.
Yeah, it'll stop running. So if Windows 11 came out and they said, the way Windows has been doing things lately, I doubt there will be a Windows 11. They're going to jump to 17 next or something. Who knows? They've been hopping all over the place for a while, haven't they?
Yeah.
I mean, so you had Windows 7, you had Windows 8, and there was a non-Windows 9. Then they...
8.1.
Yeah, that was just a patch,
Yeah.
but yeah, so they talked about Windows 9, but that never dropped, and then Windows 10 came out. So I guess we're maybe Windows 4.
Yeah, that's that same.
Makes just as much sense as anything
Yeah,
else.
Xbox 360 is much more.
Yeah,
Yeah.
exactly. But yeah, so they would have had to play this game where the software that's running on your computer right now won't run on the next version of Windows. Now, we might think, well, what if that's what it takes to progress? Maybe we say that's okay. Maybe not.
They could have done in 1980.
Oh, but they would have had to do it early. Yeah. But at that point, they had no motivation. So especially in the 90s. The 80s, they were still fighting, but they were kind of the king of the OS, but computing wasn't as huge. But in the 90s, Windows is the operating system. Today, Windows is the desktop operating system. Regardless of how popular you think Mac has gotten or something like that, the percentage of install base between Windows and Mac it's not a close match. I don't know what the exact numbers are today, but I'm confident that for desktop or laptop computers, Windows is installed on something well above 90% of them. A high number. Maybe once upon a time it was 98 or 99% of the time, and maybe they've lost a little bit of their shine and it's 96 or 5 now. But it's high. It's there isn't really. So what's their motivation to change? Why shouldn't they just be the standard? Even though from a computer science perspective, Windows standard doesn't make a lot of logic sense. But if it's not broken, why fix it? And we've seen, I think we talked about it in here when we talked about Apple switching over to OS 10. Apple switched architecture and operating system. They were a glutton for punishment. So one day they said, okay, well, we have OS 9, and we're going to go ahead and they switched operating system first. So they said, we're going to go from OS 9, which is, let's call that Windows, right? So they're old, everything works. All of a sudden, OS X, OS 10, okay? But that guy was Unix-based. That was a POSIX-based operating system, i.e. not like the previous operating system. All of a sudden, nothing works, right? So now all the people who switched to OS 10 had to wait for all the software to be ported over to OS 10. So that was a big risk for Apple, right? I mean, in hindsight, it was a necessary risk. We're still running OS 10 today. This is just 10.13 or whatever the number is. This is the 13th revision of it. It's a funny thing with Apple, because you know how Apple names each of their operating systems, like, in the early days, after a cat. So if you look back at the Apple OS X names, it should give us the history of it. All right, so we had Cheetah, Puma. Here, let's get them all. Yeah, so these were the betas. So we had Cheetah, Puma, Jaguar, Panther, Tiger, Leopard, Snow Leopard, Lion, Mountain Lion. So at this point, they ran out of cats, right?
To the house cat.
Well, they actually had Apple, if you watched a lot of Apple keynotes, which I encourage you to do. Watching keynotes from various companies, Apple is one of the best ones to look at, because a lot of times you can get, even if you hate Apple, a lot of times you can get your finger on the pulse of what's happening with technology, because Apple's a very secretive company. And if they don't introduce something you expect them to introduce, you can read into that as you're trying to maybe ask the question, why? Why isn't that feature in here? Okay, but if they're really focusing on something else, then you maybe ask yourself, well, that seems stupid. Here, I'll give you an example. Last year when the iPhone X was announced, what was the big thing with the, well, it wasn't last year, it was like 4 months ago, right? When the iPhone X came out, what was the big selling point of the iPhone X? Face recognition stuff and the animojis, right? Where you have these emojis that would have your face, match your facial expressions. That seems stupid to me, right? I was talking to my wife about it, because for a long time we've been iPhone users. I don't care. I mean, I'll carry whatever. It's just technology. So I switched to Samsung for this one, but she got an iPhone 8. She didn't want the X. She didn't want she likes the button. But in any case, we were talking about it after the keynote, and we were saying, well, why would somebody want this? So who's their market? That was the question we asked, and it's teenage girls. I mean, but you got to think about the demographic.
Yeah.
Typically, Apple products are in more affluent people's hands, right? So, if you look at the average income of Android users across the board versus the average income of iPhone users across the board, I suspect the average income will be higher for people who run iPhone. I think that's probably a relatively true statement. So now they're looking at, well, no, I mean, but we're talking average income. Yeah, you got plenty of rich people who run Android, and you got plenty of poor people that are running iPhone. But in general, we think of Apple as being a premium product.
Yeah.
People who drive Cadillacs probably have Apple. People who drive Chevys probably have Android. There seems to be some connection there, right? So we were talking about that. Why would somebody want these Animoji things? It just seems ridiculous to me, right? Well, Samsung just announced, a month ago or something like that, their Galaxy S9 and S9 Plus. What do they bring to the S9, S9 Plus? Animoji type things. So Apple has their finger on this pulse, and it ultimately comes down to money, right? Because I'm never going to send somebody an Animoji. So who knows what phone I'll have next year? I would say I would get the Samsung Note 9, but because they're coming out with the Oculus Go, which is the VR headset that doesn't, I mean, I use Gear VR, so it requires my phone plugged into it. Oculus Go doesn't need my phone. So, yeah, so I'm less married to the Samsung phone then. Once that's out, that'll come out before the next phone comes out. But who knows what I'll carry next year. Whatever is the best phone, probably, in my opinion. So I'll switch back, or I don't care. It's all the same stuff. You said you're an iPhone person, right?
I mean, I've kind of switched back and forth.
Oh, have you? So from your perspective, what's the, I have found that there's one kind of, let's call it major issue, switching between iPhone and Android. What's the one thing?
Like, say, converting like contacts over something, or like honestly, anything over like you have to convert it or something.
I find the conversion process they've really streamlined that.
Yeah,
So
it's
you have
better.
tools that go from Android to iOS and from iOS to Android that make that pretty seamless. It just takes like an hour or something like that to convert everything over.
I did it from my iPhone 4 over to my Android. That they didn't have very many good tools of that because it was. I don't know,
Yeah.
relatively new.
But also at that point in time, Apple wasn't that motivated to give a good tool, because Apple really had a pretty strong lead on Android at that point, even though Android people wouldn't have said that.
Right.
But at that point, Apple did have a strong lead on Android. Now you can look at it and say these are legitimate competitors.
Mm-hmm.
You could say you like one or the other one better, but they're both premium products. The biggest thing for me was iMessage.
Oh, yeah.
I have a lot of family members who are iPhone users. Like I got my parents, because it has to just work for them. My dad's not going to be able to mess around with Android. Actually, he probably could. My mom would. I need to hit the blue button. That's my mom. Hit the blue button. That's where the internet lives. That kind of stuff. So she wouldn't be able to switch. So, I was already used to talking to them with the blue text with iMessage. All of a sudden, they couldn't send it to me anymore. I couldn't send them that. So, I had to retrain them on how to message me. Well, now we have an ongoing conversation. So once we fixed it once, then they could just reply.
Yeah.
But that was the biggest thing, which is kind of an interesting.
Well, it does make sense because, I know, in high school, all my friends, I switched over to Android because everybody else had iPhone. I just wanted to be that guy.
You would be the different guy?
Yeah, I wanted to be a different guy, and also, I kind of liked all the features that the Android had, or at least that they were advertising. And then everybody's like, "Oh, you gotta switch back to iPhone," because I hate not having iMessage. So it definitely is they hit the market on the right type of people, I guess. So, yeah, they really do both.
Yeah, so this was the funny thing. This is this is at one of I was mentioning Apple's keynote thing earlier. So when they were telling us that they were running out of cats, you know, they this guy's up on stage, and they actually had a separate slide too where they had the seal or sea lion like hitting a beach ball. I didn't see that in this thing, but it was on there. It was on the slide set. Yeah, I don't know why I can't why they're not showing that one, but in any case, you know, they were kind of making their argument why they needed to switch their naming convention away from cats to something else, right? Because we had you had a lion, then you had mountain lion, and I was like, oh, okay, sea lion, but they had the beach ball, and I remember laughing at that quite a bit, you know, because now what they're doing is they're naming them after like landmarks. So Mavericks is something with the waves outside of San Francisco, and then Yosemite is a national park. El Capitan is some mountain range thing, right? Sierra, that's also mountains, and then High Sierra. Actually, it was very interesting when they announced High Sierra too.
When did they switch to 10 or like OS 10?
Well, here, if we can just probably count the years. So we're on version 13 now, so I'm going to say it's between 13 and 15 years ago.
Is it about one every year?
Ish, yeah.
$2001.
2001.
Okay.
So 17 years. But keep in mind that guy was, so this guy right here was written for PowerPC. That was not Intel architecture.
So that wasn't even necessarily the first one. Like they
So-
made the big switch again at Puma.
Yeah, let's see when OS X for Intel. I want to say it was Tiger, actually.
Snow Leopard?
Yeah, Snow Leopard was the first release to be available exclusively for Intel. So before that, there were Intel versions. Let's see if we can see from here when the official, when was the first one. OS X from 1999 to 2005 can run only on PowerPC-based Macs. After they switched to Intel CPUs, a separate version of, Tiger. So the first version was the fourth version of OS X, Tiger, that had an Intel version of it. You know, so you got to think about that. So right here, so we said that was in 2001. So we're still talking about this compatibility stuff. In 2001, Apple said to all their customers, by the way, tomorrow, none of your programs work. Because we're switching operating systems that are not compatible with each other. But we're keeping the architecture. You still have your PowerPC chip. We're just switching to a different operating system. So none of your stuff will work. So they dealt with it probably somewhere, you know, halfway through the year here, stuff started working. Stuff was probably working pretty decent. So right around in here, Apple finally said, by the way, tomorrow, if you're going to buy a new Mac, it's going to have an Intel processor in it. None of your programs are going to work. Again. So 3 years after they cheated death. I mean, Apple was on the fence at this point already. I mean, this came after the iPod was already out, so Apple had recovered quite a bit. But remember when we talked about this, Apple was on hospice, right? They were in trouble as a company. So, you know, this is really Apple cheating death to get past that, to survive that compatibility issue and still stay afloat. I mean, that's really evidence that people are truly drinking the Apple Kool-Aid, right? But then to get here and say, okay, well, you know, it worked once. Let's screw our customers over again. Why not?
A lot of people look at it like, oh, what are they going to do? Switch it again? Here in 3 years?
No, I mean,
Or are they pretty confident that, like,
see, the issue you run into with anything with consumers and technology is people like us that try to focus and understand the technology this move made sense. Okay, so making the move from this move made sense as well. So making the move from OS 9, which had obvious technological glitches, to a Unix-based operating system made sense. But the transition is gonna be painful. All right, but it made sense. Similarly here, it was clear that Apple was having problems producing PowerPC chips. IBM was creating them for them. And I mean, really, the chips were very expensive, so it was hard to keep the price. Apple's never tried to make things cheap, but they were having problems competing even at their level. It just made sense. I mean, RISC did not win. The Intel expanded architecture made more sense. So, again, from a technologist perspective, we're going to say, oh, well, they're switching to Intel. It's about time. But again, it's going to hurt for that transition period. That transition should have been easier because remember, what did they have to do then? They basically have to go back through and recompile the code with a compiler that didn't just know the PowerPC architecture. Now it knew the Intel architecture, but at least the underlying operating system is the same. Make sense?
Yeah.
So this made sense, but to the average consumer, they might look at this and say, well, why is my stuff stopped working 3 years ago? Now it's going to stop working again. It would probably be a pretty similar thought process to an iPhone user today or something when Apple changes the dongle, changes the cord to charge it. So if you've been an iPhone user for a while and you have 20 different iPhone charging cables around your house, and all of a sudden you get the new phone and it's a new charging cable. Like, none of my charging cables work anymore. I need this new one. And I need 20 more of those. And then you buy, you go online, you buy a bunch from China, and only, like 1 out of 12 work. Something like that. Because Apple has like this extra special little wire in there that just makes it, that way you have to buy their $30 cable. It's a racket. it's a racket.
I was just curious looking at Intel, because Intel would have benefited from this, like, hugely, right, when they made the switch to Intel, right?
Intel's done all right.
So now it's, yeah, right. So that was at 10.4, so that was like in 2005-ish?
Yeah.
Okay, because, like, I was just curious, I looked at Intel stock, and it really spiked in 2001. Would that have been a big moment for Intel when they switched over operating systems?
Not necessarily.
Okay. I was just curious if something else.
Yeah, so to look back at 2001, maybe something to focus on there is if you look at AMD stock at the same time,
okay,
there was probably a drop in AMD stock.
Okay. It's like huge compared to everything else.
Yeah, so AMD had their AMD 64 chips that came out too early. So I'm thinking that big spike might have been the alternative spike to AMD's struggles. Does that match up or not?
No, actually, AMD spiked up at that time.
Okay, so there must have been something
Yeah.
technology-wide.
It's completely unrelated.
I mean, it's not necessarily unrelated.
Yeah.
I mean, these are interesting things because things like that in technology typically do drive the market for architecture.
Mm-hmm.
You can't look at Apple price and take anything of it because Apple is one of the stocks that the various funds push up and push down to drive the market because it's a big enough market mover to do that. So sometimes Apple's up when there's bad news and they're down when there's good news, and it's kind of meaningless.
Yeah. Right.
But yeah, it certainly would have been good for Intel in general because now more computers have their chips on it in it. But if you actually look at the numbers, though, would that many more chips have that many more computers have it? I mean, there's not that many Macs.
Yeah.
Relative to the number of PCs.
Yeah.
So I mean, fine. They picked up customers, but the percentage was
because it was 98%.
Something like that. Yeah.
Okay.
Yeah, but the point is this is all very, very interesting when you just look at kind of the history of this and we see this compatibility stuff happen. When Microsoft never gave in because they didn't have to. Apple had to. This was survival. Okay, this was survival again when they switched to Intel. They had to do it. They came out the other side smelling like roses, like lucked out. But Microsoft never actually had to do it, and I don't think they ever will. Because what are we going to see happen now? I mean, is anybody ever going to take over Microsoft as the top desktop operating system? Are they eventually going to get dethroned?
Unlikely.
Why not? So you're going to just be running Windows forever? You're running Windows right now, right? Windows 10? So you'll just, in 20 years, what operating system will you be running?
We are not sure whether we use desktops or not at that time.
See, that's the point.
Yeah.
So I think it's unlikely, but not because Microsoft is perfect. I mean, desktops are already used far less today than they were 5 years ago.
Yeah.
I mean, in fact, how many of you do true productivity stuff on your phones? I mean, how many of you have ever dictated almost a paper on your phone and then gone through and fixed the voice dictation errors or something like that? I mean, we use our phones now for productivity tools. It's not the fact that it makes a phone call is just an extra feature, right? You got to go find the phone app on your phone. Where's my phone app? By the way, I have to put the phone app in the very bottom left-hand corner of my mom's phone. Otherwise she can't find it.
I think it's funny we call it a phone now because it does so much more than just calling. People don't even use it for that.
Yeah.
I could completely live without it making phone calls.
You could, yeah.
Me too.
I hate phone calls.
Really.
Oh yeah, the only person if my wife's calling, I'll always pick up because that means she knows not to call me. So if she's calling, there's like it's an emergency or she needs to talk to me now. So I'd even pick up like during class if she's calling.
Right.
My mom, I've trained her now to text me. Okay, because my mom's the real risk. See, a phone call with my wife is going to last 30 seconds. She's efficient. So, it's like, this is what I need, blah, 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 phone call's over. The phone call with my mom lasts anywhere between 5 minutes and a week. I love my mom, but those are long calls. Okay, so when you pick up that phone, when there's a call coming, you're making a commitment, potentially for the rest of the day. And I might have things to do. I have actually once, I think maybe more than once, I've answered a call from my mom in class and put her on speaker. Let the class
That's
talk.
hilarious.
We can call her now. My mom's funny. But yeah, she's she's an old Jewish lady. So it's,
Isn't she here around this time?
she's in Champaign, Illinois, about 4 hours away. Yeah. Edwin slept in my mom's basement. That's creepy. we went to a hackathon there. We stayed the night at my parents' house. What's this? Well, yeah, until you guys showed up. It's just 2 people living in this giant house. All right, so in any case, this whole compatibility issue is something that has been going on for a long time, right? And we've seen real tribulations come through it. And we were just talking a minute ago. So what's our computers going to look like 10 years from now? We already see our phones becoming more and more productivity tools and becoming faster and faster and faster. How long is it gonna be until we just have a keyboard? Let's say keyboard and mouse, or at least mouse stays around. We have a bigger screen and a keyboard at home, and we just come and dock our phone, and now that's our computer.
Yeah.
We're working on that, and what really drove the experience is the size of the screen. We wanted a larger screen. I think the same thing could happen. Especially with virtual reality, if we get to the point of having good I/O functionality in VR. You know, because the real issue with VR right now from a productivity perspective, and it's actually another interesting conversation. I think I showed you mixed reality a couple weeks ago, right? So 3 weeks ago, whatever it was. You know, is Microsoft's kind of future approach to this is that you no longer have a desktop that looks like this. You now your home is your house. Well, so that's cool for 5 minutes, but does it make sense? Well, until we have good I/O devices in VR, it doesn't, right? I mean, I can probably get by with having to use the controller to point and click. That would probably be okay, but it's not as good as a mouse. Mouse is more precise. You know, you certainly to type, you know, if you go into mixed reality and you click on the web browser and you want to type something in, it brings up this giant keyboard in VR. And you basically have to, you know, tap out your thing. You know, it's kind of like, you know, putting in a password or something like that on an Xbox or a PlayStation, where you know it's not fast, right? That's not productivity based. You're going to need something better than that for input-output devices on a, you know, in VR in order for VR to become your new productivity tool. I mean, VR has all sorts of cool stuff in terms of having like lots of monitors. You ever been to somebody, or maybe you're one of these folks that has a computer with the 4 monitors, something like that? Well, in VR, you could put 20 monitors, have it all around you, and have each monitor the size of a movie screen. You know, there's nothing that keeps you from doing that because you're not bound by physical space. Yeah. Well, that sounds great as long as you be productive in that environment. Yeah. So that's where we really need the keyboards. So it becomes kind of an interesting thing. I can kind of see us maybe having a kind of a newly designed mouse, because I think you can use a mouse pretty efficiently in VR. Like you don't have to watch your hand in VR. But a lot of folks for a keyboard, you know, even though you're not looking at each key, you kind of need to know where you're starting from. Mm-hmm. So I think if you could have a keyboard show up in VR that was like the keyboard itself was kind of touch sensitive. So you got, like when you first laid your keys on it, your fingers on it, you would, like the keys you were touching kind of highlighted in VR. So you had a context of where it was. I think if you had something like that, you could make it productive then. You know, because that would bring it into VR, but you'd still be using your hands. So now it's, you know, the keyboard itself just gives you a virtual representation of itself, but kind of lets you know where you are on the keyboard or something like that. You know, it's going to start with hand tracking, and we already sort of have that. There's a device from Leap Motion that allow you to track your actual hands. And then we're going to have haptic gloves and things like that. But as those things start coming together, our future operating systems might be all virtual. Everything might be done in VR. Or, you know, it feels like that's going to be the way it ends up being, right? But is it going to be VR like that, or is it going to be like VR like we have in the books? You know, where you basically plug in and now your whole consciousness is in virtual reality. You're not wearing a headset. You're asleep on a bed, and you're in a virtual world. Maybe that's what it's going to be. You know, who knows? I mean, that seems cool to me, right?
Seems a little creepy.
Does it? Would you do it?
I don't think so.
So let's say that there was a company that has created, you know, so we have the Ready Player One movies coming out pretty soon based on this pretty cool book where there's this virtual world called the Oasis that you put a VR helmet on, you're in the Oasis. But what if you could, let's say there was like an Earth 2, a second world, and, you know, it was like here, but let's say different than here. So it had some perks. Things were nicer or something like that. We hadn't hurt our environment as much or whatever. If you could just be, you know, almost like the movie The Matrix, right? You know, you just be sustained alive here, but you're plugged in. And as far as you're concerned, your real life is there in a virtual world. Would you do it?
I don't think so.
Really?
Yeah. I don't know. It's just, I think there's like some ethical problems come in there. Like
Oh, I mean, I think that's easy to argue that there would be. You know, there's definitely conversations that would need to be had. I'm more asking just as on a personal level.
Oh, just to think how cool it is?
Just would you try it? Let's say they were beta testing it now. They're not making a decision that the whole society is going over there, but you know, look, we'd like you to go in for 3 months just to see what it's like. We got nurses and stuff watching. We'll make sure you don't die. Okay, we're gonna have you go in. We'll have you go in for a week first. Make sure everything's good. We'll pull you out. We'll ask you questions of that. We'll make you go in for a month.
We did have a movie
Oh, it's, yeah, like Inception. Yeah.
Yeah.
I don't
And
know.
then also they put you in for, you know, it's gonna they have to make sure they can keep you healthy and
Yeah.
keep your muscles stimulated or whatever, so your real body doesn't die.
I mean, I like at first, like obviously I want to, but then I'm like, I don't know what's going on. You're like, you don't really have control on the outside. I mean, yes, you're in that the other world, but like you're still not in control of yourself. And then you're like, the reality becomes, or that virtual reality becomes your new reality in a sense, like almost like in the movie Avatar. Yeah, something like that, or Inception, sort of a little bit. I mean, there are movies, but it's kind of like it's an interesting fact. Like you're in a better place. Like you get to create everything the way you want to be, rather than living in a world where you are created who you are, and you're learning to deal with what you have. So I think it's kind of interesting, and I think you might, when you come back to what is real, you would be disappointed almost.
Well, so I'll throw another curveball. What's real?
Oh boy.
So Elon Musk has talked about this recently, I've read about it in some of the books that I've read. I'm trying to think of the name of the series, but it's called "The Game Is Life."
Okay, I know where you're going.
Have you
I've heard of this a little bit.
Okay, read the book.
Yeah,
it's a whole series. It's really good. But so the premise of The Game Is Life is kind of what we're talking about here, where you're, would you go into this virtual world? Because kind of the idea of The Game Is Life is, so most of you are 20-something, right? So you've had 20 years on Earth to learn stuff, and you know a lot more today than you knew when you were, 2. All right? So let's say that you die when you're 80. Okay, so when you're 80, do you think, forget about being senile and stuff, but do you think from a lifetime of experiences, do you think you know more at 80 than you know now? Yeah, you had 80 years of knowledge. So the way it worked is you would go into the game, and from your perspective, that was life. You lived a whole lifetime. You would die, and you would accumulate points during the game. So for instance, we're all in the game right now from this book standard. And when we kick the bucket, we've tallied up points based on the way we've lived our lives. All right? And we also learned a lot. And then, based on the points we have, we can go back in and live another life. So it's almost like the reincarnation story, but you're kind of see what I'm saying? But you're going in, it's like another play. So in the real world, when you play the game, a whole lifetime is like 2 weeks, the real world. But to you, it feels like 80 years.
That's crazy.
All right, because you're in the game. But you would have some of the best players might go in, and they might be on their 9th or 10th lifetime. So imagine how much you would learn if you could have 9 or 10 lifetimes. Maybe you were a surgeon in one of them and an Air Force pilot in another one, whatever. The accumulation of knowledge you could get with that, right?
Wow.
So that's kind of an interesting, it was originally created as a way of replacing education in this book.
Mm-hmm.
Well, but then the twist is the real world was actually a virtual world. So that world that the game existed in that was taking 2 weeks for a whole lifetime was actually a simulated world too. So you mentioned that this is real. Like, oh, well, I want to come back to my real body. Well, this isn't your real body. You can kind of see what I'm saying?
Well, no, that's
Elon Musk recently said something about that he thinks we're living in a virtual world. Yeah.
I mean, that literally is like the movie Inception too, because like they get into it and then they go another layer down and then like
that's it.
It's like same thing.
Yeah.
That makes you think.
After Elon Musk said something about that, I think there was some conversation about how somebody was trying to come up with how can we test that this reality is the reality or something like that. At some point, you just have to not worry about it.
Yeah.
Maybe you just have to think about like I have aches and pains. I'm getting a little older in this reality. If I could go fresh into something. Jack, do you want me to go in for 6 months? It's fine. It's fine. Where do I sign? But even if we take something that's less invasive, so we're still talking about the future of computing. So before we're in unconscious virtual reality, we're going to have other, right now we're still in this trend of wearable devices, right? So before long, we're going to have like smart contact lenses. In fact, there's already prototypes for these things, where you would put a contact lens in, and that is a computer screen. So it would provide augmented reality on your reality through this contact lens. So would you wear something like that? Would you think that's cool?
I think that's sweet. Yeah.
Okay. What if they had to replace your eye? Okay. What if the contact lens can only accomplish so much? Look, it's a little contact lens. We can only get so much into a contact lens. We really need for the computing power that you desire, we need to give you a whole new eyeball.
I mean, because then you could argue, well, I'm putting my trust in something that we built, and then because essentially that could fail. I mean, granted, you could also argue that your eye is going to fail regardless, but I mean, what's the point behind it? Just for a cool factor, or is that how you function in society? I mean,
Well, you would be an early tester, so we're still in the early tester type thing. So kind of, I mean, I think the future of how we will live will be augmenting, our realities, right? And it just makes a lot of sense. But at this point, we have the issue of we're strapping these headsets on and stuff like that, or having to stare through your phone. I was giving a presentation earlier, and we were using the new IKEA augmented reality app. So if we want to see what one of IKEA's couches looks like right here in the middle of the room, we can just plop it here in the middle of the room on here, and we can look at it. Yeah. See the size, turn it, it'll look better over in this corner, and then we, but you still have to look through your. What if you could just stare at it and says, open up IKEA's conference, whatever, catalog, pick out the thing, plop it there, and I'm just looking at it. I didn't have to hold a phone up or anything like that. It'd be pretty sweet, wouldn't it?
That'd be cool.
Same thing with golfing. I wouldn't have to look down at my app for getting yardage. Just look out there and says, that bunker's 210 yards away.
Yeah.
That tree?
Yeah. Wasn't it the idea with Google Glasses?
Yeah, same thing.
Take off,
No, I mean, I have a set of Google Glass. I mean, it's interesting. Battery life is very poor.
You have them?
Yeah. I have everything.
That's cool.
Yeah, if it's technology, I'm pretty geeky, so I get most things. But the battery life isn't very good, and that really failed because of privacy issues, because you had people going around recording other people. But Google Glass actually has made somewhat of a comeback in the corporate world. So they have a version of it, I think it's Google Glass Enterprise or something like that, that is really for communication in corporations, talking to each other and that kind of stuff. But so you're dancing around the question. Would you replace your eye?
I don't think so.
Really? Any of you? Man, I would probably let them replace both eyes. If they were pretty sure it was going to work, and I was going to get a way better feature, if we do both eyes, you'll have really good resolution, and man, the power that you will have will be just awesome.
Well, then
all right, let's do it.
Stop though with that. Okay, well then we can also cut off your arm and make you have an arm.
Look, I could use some new knees. Let's start with this. So if I can get the Terminator knees, I'd be down for that. Let's get some titanium in there.
We're doing that in a sense, replacing joints, but so then where do you draw the line with what you're having control over what's going on in your body? Because I mean, okay, now my eyes can be hacked. What's the security running on your eye?
That'd be really funny. It's you're just sitting there. It's what's going on? My eyes are hacked. I don't have control over this. That would be awesome.
I don't know. I think there would be a lot of issues that come up with that. I mean, initially, yeah, I'm that idea. That's cool. The fact that you're thinking of that, and the fact that you could do something like that, but I don't know if it's the right thing to do.
Well, but what's right?
Yeah.
Yeah, so I mean, now we're getting back to like ethics and
Yeah.
stuff like that. Yeah, so I mean, this is more. I'm not sure that's right for society, but I would definitely sign up for it.
Yeah.
Like I would do it.
You do.
Yeah.
And people like you can easily change the eyes because I do not want to be in this place.
Oh, so you would change your eyes.
Yeah. Because now I
Well, why don't you wear contacts?
contacts, I have to take care. I have to wear that I cannot watch the face.
Well, you can though. So I have daily contacts. So every single day I have a brand new contact lens I get to put in. I open a little package and there's a brand new lens. At the end of the day, I take it out, I throw it in the garbage can. Fresh contacts every single day. If I lose one, I'm out $1 or whatever, whatever it costs.
Do you have to do that way, or you can use it longer?
You can use them. Well, I use daily, so they're a little bit thinner. They're meant to be thrown away every day.
Okay.
Then there's ones that are 2 weeks, and there's 30-day ones, and then there's permanent ones.
But at least every day you have to.
That's true, but it takes no time. Like from when I wake up to put my contacts in takes 30 seconds.
I tried some 3 days contact, but it's hectic.
Yeah. I mean, for the first week or two, you're going to get used to it, right? But then after that, you just slap them in, no problem.
Initially, when I started using lenses, I was always in an impression that when I would break it, they would slip inside. It was terrible.
Mhm.
Yeah.
But you could wash your face. You could take a shower. You could go swimming with them in.
Even though you can see it like for 1 hour.
Yeah, you could take a nap.
Yeah, you can.
I mean, you could sleep longer than 1 hour. I mean, you can. I've slept for 3 or 4 hours with them, and you wouldn't want it if you slept with them overnight one night. It wouldn't be the end of the world, but you would definitely want to take them out.
Does that. So you just forget to sleep overnight and
Yeah. But you wouldn't want to do that often, because then you start having to deal with eye infections and that kind of stuff.
Right.
But yeah, so you could get away from the glasses rather just by going to contacts. And if you replace your glasses every year, the cost is about the same. If you only replace your glasses once every vernal equinox, then you're probably cheaper with glasses. Yeah, I would replace my eye in a heartbeat.
Really.
Oh yeah, I replace my knees. I would probably replace just about everything except my brain.
Okay, that's what I was just gonna ask. If they came out with a better brain, or what they claim to be a better brain, and you could think twice as fast.
Well, maybe actually. See, I'm very intrigued by technology, and I'm an early adopter for things. So I would say, yeah, maybe I would.
You try it.
Yeah.
You're the guy that tried.
Because I mean, I don't have anything to lose.
Yeah.
I mean, I've already done my school. I've done my business stuff. So it's the worst that happens. I become vegetable lasagna. I'm eating through a straw. That's the worst that happens, right?
Right. Yeah, I guess so.
Yeah, and then I'll probably get one of those really good wheelchairs that like the go-kart ones.
Yeah.
Be awesome. All right. How do we get off on that tangent? Oh, we were talking about compatibility. How do we go from compatibility to replacing your eye? I don't even know. All right. So there will probably be some compatibility questions on the exam. So all that stuff we just talked a lot about. The difference between the compatibility for something on an operating system versus the compatibility on something on an architecture, and those things are different levels of compatibility. So I would ask some question that would prove that you understand that concept. It might be more of a scenario type thing. I think I said earlier. It might be like, if you had a C program that was compiled for Linux, would that program on an Intel processor, would that program run on Windows running with the same Intel processor? Something like that. And the answer would be no, it wouldn't, because even though the architecture is the same, the operating system is different. Therefore, the low-level assembly code would be different. I might put a bitwise thing on there. We didn't really have an applied use for them at this point, but you should be able to do bitwise shifts. They should be pretty easy. I doubt I would do a bitwise shift. I'm more interested in bitwise ands and ors. So bitwise operations with ands and ors. So again, just mathy stuff. We talked about this idea of masking, and I can even give you an example of that from a C program we're working on in the other class. Yeah, so we're creating some shared memory in a different course, and notice here that this is some value, this is some value. We're bitwise ORing those together, and this is going to give us the masking of these two things together is going to give us our protection for this shared memory we're getting ready to create. So this is an example of using bitwise operations inside of programs. So these are kind of options. Similarly down here for how this shared memory is appearing to other people. Don't worry about what shared memory is at this point, but we want this to not give away who created it, and we also want it to be shared amongst all processes on the computer. So since we want it to have both of those things, we are ORing these together. So this, whatever this number is and whatever this number is, we're going to get a result that is those two numbers masked together with OR, giving us our actual final visibility thing that's going to get set in this variable. And then we use that to use mmap to create some memory. Okay, so there's an example of a real-life application of a bitwise operation. That makes sense? And there's plenty of other examples like that, but that's kind of the most common example. If you have 5 or 6 options, almost like filters you want to apply to something, you would OR them all together, and that becomes that combination of those 5 filters is the answer to that you would then store. Certainly understand the difference between an immediate value and a register value. So immediate values are constants, are literals. And then be familiar with your, the add versus the add immediate. Similarly, the and immediate. So this is doing the bitwise operations on either immediate values or between two things. Similarly with OR.
So will we be getting what kind of questions will we
we might move some stuff into a couple of registers. So I could give you something like, I might say that register, so let's say X1 has a 5 in it, X2 has a 22 in it, something like that. And if I said that X3 was equal to OR of X1, X2, what would the result be in X3? So you would do a bitwise OR of X1, X2. So you'd have to convert those decimal numbers into binary, do the bitwise OR of those two, convert it back to decimal, and that would be the result that would live in X3. Something like that. So be able to do those bitwise OR operations, the bitwise AND operations. All right, we did talk about the hackathon last time too. So if you haven't signed up for this, sign up for this. Anybody in here, has everybody signed up? And you've picked a preference? Who picked VR? Oh, the rest of you are VR'd out? So you all picked mobile apps? You picked Android mobile app? Really? You didn't like VR?
I did, but I wanted to do it for now. Before I leave.
But we're writing Android in here. You could make a bitwise OR operation in Android. or not in Android, in VR, where you walk up to 2 bits, and then you need to decide what the OR of that is. Then you have to you have a little toolbox up there. You grab the bit out of it. That's your answer, and you place it there. You could physically do a bitwise OR in VR. That's exciting stuff. That would make like no money.
Yeah.
Make nothing. Certainly, how characters are represented, understanding the Unicode character set, how everything ultimately becomes a number. I don't know how I would necessarily, how I would ask a question about that, but well, I mean, it could be something as I might ask you to explain how characters are represented in modern computer architecture, something like that. Like if we have the letter A and we want to store the letter A in register X1, how does that happen? Well, we have to get the Unicode version of A, convert that to binary, and that's what ultimately gets stored in X1. And then when we go to use that, we have to then map it back to its Unicode position to find out that what we should actually be displaying is the A. So understand that we're storing it numerically with the intention of mapping it back when we actually need the character version of it. Be able to do binary math. Really, you should be able to do math in any base. It's the same pattern. So depends how evil I decide to get. Hexadecimal math would be fair. Base 13 math. Well, base 13 math isn't any different than base 2 math or base 10 math. Just when you carry, you're carrying in chunks of 13. That could be a fun one. Especially if we start getting those Klingon characters. Base 51 math. It's like, well, what's 51 in Klingon? I think it's how you pronounce it. I don't know. I didn't remember. There maybe got grunt in the middle. Yeah, it's the 51st character. We can look it up later, but I want to look real quick. Klingon alphabet. Look at this. You got this. How do we pronounce those? Pronunciation. Sounds of Klingon. There's a Klingon Language Institute?
Bob. Bob.
That's Bob? Let's get to one of these weird ones.
Mom. Cluck. Vav.
There will be a question on the exam where you have to stand up in the middle and you have to, there will be a sentence written in Klingon. You must rise and speak it in perfect Klingon. That won't be on. Okay, but you should be able to do math in any base between base 2 and base 36. Certainly the idea of how signed numbers are represented. So that whole idea of I would be asking about sign and magnitude versus 2's complement versus 1's complement. Even so, sign and magnitude just uses the first bit to hold positive or negative, right? And then the rest of the value is the number. So you get a 7 2 to the 7th power is if it's 8 bits. One's complement. What's the difference between one's complement and two's complement? Why do we choose to use two's complement for storing sign numbers rather than one's complement or sign and magnitude? What's the disadvantage of sign and magnitude and one's complement?
Can't you represent one to one?
Yeah, why?
So like you get 8 to 8.
Yeah, because we have a negative and a positive 0. So in sign and magnitude as well as one's complement, we have a double 0. We don't need more than one way of representing a 0. So two's complement allows us to represent, for a byte, negative 128 to positive 127. So we get an extra value on the negative side. All right, so be able to represent numbers using sign and magnitude, so negative numbers in sign and magnitude. Similarly, be able to do it in one's complement. Similarly, be able to do it in two's complement. So notice here, well, sign and magnitude is pretty straightforward, right? This one's the easy one. You just flip. All the negative numbers have a 1 in the first bit. All the positive numbers have a 0 in the first bit, and then the other 3 bits are the same. If it's a 7, it's a 7. So on and so forth. Okay, so that one's trivial. One's complement, that's where we flip all the bits, right? Okay, and notice that for 0, we have all 1s or we have all 0s. All right, so 2 different ways of representing a 0, so we're going to say that this is actually the problem with one's complement. It's a little problem, but it's a problem. Okay, but a 7 is different than a negative 7 is different than a 7 for those last 3 bits because we've flipped the bits. So a 7 is 0, 1, 1, 1. The one's complement of that is 1, 0, 0, 0. So that's a negative 7. But you have to know it's in one's complement for me to say this is a negative number. This guy's in one's complement. Make sense? Notice that the left bit of all the one's complements is a 1. The left bit of all the of all the negative numbers is a 1. Of all the positive numbers is a 0. So it's similar to sign and magnitude from that perspective, but we do get a double 0. One's complement was we flip all the two's complement rather we flip all the bits and then we add 1. All right. So 0, 1, 1, 1 became 1, 0, 0, 0, and then we added 1 to that. And that gave us our negative 7, 1, 0, 0, 1. That make sense? Okay, but then we get one extra representation. So instead of having an extra 0 over here, so a 1 becomes a 1, 1, 1, 0 or a 1, 1, 1, 1 because we added a 1 to it. Two's complement says flip all the bits, add a 1. So that's why 1 is 0, 0, 0, 1, and a negative 1 is 1, 1, 1, 1. Make sense? But we didn't have to have 2 zeros. So what did we have here? We had a 0, flip all the bits, that's 1, 1, 1, 1. And then we add 1 to it, and we get 1, 0, 0, 0 with a carry, actually. But that's our representation for the negative 8 on this side. That make sense? Where in the other ones, that was our other 0. All right, so be comfortable with sign and magnitude for things. I would think the question would probably be one question, and I would probably ask something along the lines of, show me the number, I don't know, 27 and negative 27 in sign and magnitude, one's complement, and two's complement. Something like that. Have you plot those things out. Okay. All right. I think that's enough stuff. Will I get me 10 questions?
Like you're gonna be like 100 questions.
100 questions.
Yeah, I feel like
You're only gonna have 15 minutes to do this thing.
No, good.
no way.
That's bad?
No, that's good. That means you can't expect us to write a lot, right?
Well, no, I can still expect you to write a lot. She wanted me to be in the hospital. You think I've forgotten that?
I thought so. I thought you forgot.
No, see, as these chemicals are coming out, the memory's coming back. See, I'm old, but I'm lucid.
I felt you forgot because that was in the session you were going into because of the chemicals. I thought you forgot because of that.
No, we're still good.
That's a memory from that session after your am I right?
Yeah.
So you're supposed to forget it.
No.
It wasn't real. This isn't real.
That's right. See, I'm just chilling in some hospital. I'm still in the hospital. That's
Yeah,
the...
that's it. This is
Classes. We did you have class today? All right. So exam will be next week. There'll be 10 questions. How much time do I want to? All right. So here's the scoop. I'll let the class decide. If we only take the test, it's going to be a longer test. Still only 10 questions, but I'll put harder questions on it. I'll just give you more time. So, you could have the whole 4 hours if you want it. But it'll be, worse math. Otherwise, we can make the, questions, I guess, a little, less mathy, but still math. It'll be a similar questions, just, you would have to do like less thinking. It would be more straightforward probably. And then, so maybe we can do 2 hours for the exam and then 2 hours of new stuff. Which you want a really hard exam and have all 4 hours to work on it? You can just leave whenever I'd probably design it to take an hour. If you you exactly knew what you were doing, but you can have all 4 hours to work on it. Or I'll design an exam that should take an hour, and I'll give you 2 hours to work on it, and then we'll spend 2 hours doing new stuff.
I don't know.
What do you think? I'm fine. I'm fine as long as you don't show me up in my paper. It's not showing my paper if I'm not.
Well, it's going to be impossible. Either way, you're all going to fail the exam.
Oh my God.
Let's just start with a baseline.
So, yeah, it's supposed to be easy, then I hope 2 hours.
No, I didn't say easy. Okay, I said you can have a 4-hour impossible exam. I mean, truly impossible. Okay, or you can have a 2-hour mostly impossible exam.
That's what you meant. You meant
Go with the mostly impossible.
Now, what I really should do is I should come in and I should have a mock exam. Okay, I'll have the real exam like in a drawer or something. Can we pass out this exam? 3 of the questions are on Klingon, and I mean, the exam just seems completely unreasonable. Just like, what am I looking at? There's weird physics formulas and stuff like that. And then you start asking questions about it. I'm just super rude. Like we talked about this in class. Okay. Then Romana starts crying, and that's what you get for putting me in the hospital. I got a camera going. I'm just recording the whole thing. I had an extra credit question on an exam years ago that I gave, and it was, the whole back page was this whole big extra credit question. It just looked intimidating. It had all integration problems on it and stuff like that, and it had some given words, it was talking about given the known celestial body Vega is traveling at 6.8 atmosphere, just crazy type stuff. You had to read through the whole page, so. In the end, it was either, prove that in the, vacuum of space, something, or just draw a smiley face with a mustache. You had to get through all the questions. All right, so we decided on I'll write a 1 hour test that you'll have 2 hours to take. So there shouldn't be you'll have plenty of time to double check your math or whatever. So the only real risk will be is since everybody has 2 hours to take it, if you finish early, you'll have to go chill for an hour somewhere and relax. So then we'll come back at 8 p.m. and start talking about new stuff. Sound fair? Questions, comments, concerns, bribes? All right, so then I want to look at something. What have we read up to in the book? I'm not going to give you a big reading assignment, but I want to push you to the next stuff we're going to look at. So remind me. Oh, you don't even need to remind me. All right, so we are.
When is the exam next week?
Next week.
Only Sunday?
Oh man. Next week's. Yeah, we can't have it next Thursday. Ay. We have another 2 weeks off?
Just a week. 1 week off.
All right, hold on. I got to rethink this. Well, because the plan, so we don't have class next Thursday then, right? All right. Same plan for 2 weeks from today, but I'm going to give you more to read. All right. So let's do let's do 3 and 4. Let me make sure everything in 4 is. Yeah, I mean, you have 2 weeks to go through this. So no exercises, just complete all the stuff in 3 and 4. That'll give us lots of runway to talk about stuff from that point forward. Make sense? So chapter 3, chapter 4 from the book, and then the exam 2 weeks from today. And then no class next week. Sound fair? All right, questions, comments, concerns, bribes?